Welcome DIKWP, 小工 aboard. Your learning journey starts now. Patents are a semantic minefield. Traditional methods, they stumble. BERT is better, but still blind to the inventor's real why. We need something smarter, something that gets the intent. So, what's DIKWP? It's not just data, information, knowledge, wisdom. We add purpose, the why. Think of it as a cognitive loop, D to I to K to W, but also P driving back down, constantly refining. Data is your raw facts. Information is the difference between them. Knowledge is when you structure that info. Wisdom is the big insight you glean. And purpose. That's the North Star guiding every step. It's not linear. It's a dynamic, feedback-rich system. This structure allows us to mathematically define each layer, like using an operator psi to build knowledge from information chunks, or omega to score outcomes based on intent. It's about making the cognitive process explicit and goal-oriented. Now, how does this work in practice? Enter the four spaces model. Imagine concept space as your neat, tidy ontology. Neural network is clearly defined. Then there's semantic space, messy, contextual, natural language, like CNN algorithm or deep learning technique. Our job is to map between them reliably. We use a mapping function, f, ideally bijective, so concepts and their linguistic expressions align perfectly. This isn't just theory, it's about creating a bridge. The AI needs to understand the pattern surface, meaning semantic, while grasping its underlying technical structure, conceptual. This interplay, especially with the human expert's cognitive space feeding in, is key to taming patent complexity. Okay, patents are tough. They suffer from the infamous 3 no problems: incomplete background, inconsistent jargon, imprecise descriptions. Standard systems choke on this. But DIKWP handles it elegantly. By decomposing these issues across our 4 spaces, we can pinpoint where the ambiguity lies. Is it a missing concept in the concept space? A conflicting semantic interpretation? An unclear link in the knowledge graph? This granular view lets us tackle uncertainty systematically. For instance, a fuzzy term in the patent text might be flagged as a potential issue in the concept space during mapping, allowing targeted clarification or refinement. It's about turning chaos into manageable data points. Does it actually work? Let's look at the numbers. We used cosine similarity to measure patent vector closeness. Compared to standard BERT and TF-IDF, DIKWP blew them out of the water. Top 5 retrieval accuracy, a whopping 92% for DIKWP versus 78% for BERT and a measly 52% for TF-IDF. Visualize the embeddings with TSNE. Clear, distinct clusters for each patent category. Why? Because DIKWP's concept-driven approach forces the model to learn meaningful, discriminative features, unlike black box models that might latch onto irrelevant patterns. The key takeaway: injecting intent and structured knowledge representation dramatically boosts performance. So, why should you care? DIKWP offers precision beyond keyword matching. It provides explainability. You can peek inside the model's head to see which concepts it's using. And it's not just for Chinese patents. The framework scales. Think multilingual analysis, cross-domain insights, even analyzing entire patent portfolios. This isn't just another algorithm. It's a new way to think about understanding complex, intention-laden texts like patents. It empowers you to get smarter, faster, and more transparently. That's the power of DIKWP.